we're going to solve this compound linear inequality. So we have 2x minus 3 is less than 3 and 4 minus x is greater than or equal to 5. So what we're looking for are the solutions that work in both inequalities. So we'll solve one at a time here. So on the left side, let's see, we're going to add 3 to both sides. We're trying to isolate the x, so I have 2x is less than 6. And we'll divide both sides by 2. And that gives us x is less than 3. So on the left-hand side, we get x is less than 3. We're on the right-hand side, let's see, we're trying to isolate the x. So how about if I subtract 4 first from both sides? Now be careful, this is still negative x. So I'm going to write that as negative 1x because that's what that really means. And then 5 minus 4 is 1. And now we need to multiply or divide both sides by negative 1. And remember what happens when you divide or multiply by a negative number? It switches the inequality sign. So instead of it being greater than or equal, it's actually less than or equal. So on the left-hand side, I've got just x is less than or equal, right, to negative 1. If you want, you might want to circle that so you don't forget. That's the one you're going to use. And this was and, right? So we want numbers that are less than 3 and also less than or equal to negative 1. So first of all, just think about that. What do you think the answer is going to be? You want numbers that satisfy both of those inequalities. So one way of doing it is to graph each of them. So let's graph x is less than 3. And remember what we do if we graph it, we just look at the overlap. So let's say this is 3 and that's 0, for instance. Then if I want less than 3, it's going to be the parentheses, right, or an open circle. This goes forever, right? Keeps on going. And let's go ahead and graph x is less than or equal to negative 1. So we want to line up our numbers the same way. So here's 0 and 3. Then less than or equal to negative 1 would be here. So the overlap, if you look, is about right here and then to the left. So it's at negative 1. So the solution to this will be, now it's going, sorry, I did that wrong. The solution is actually x is less than or equal to negative 1. If you were to write that in interval notation, you would go to the left forever and ever. There's no smallest number, so we write negative infinity with a parentheses on the left. Always the smaller number on the left when you use interval notation, larger number on the right, and it goes up to negative 1 and touches it. So that's the solution in interval notation. Now if you were going to graph it, actually that's the graph of the solution, right? Because it happens to be that x less than or equal to negative 1 is also the solution, even though it was just one of the pieces of the compound inequality. So here's an example, unlike the ones we've done so far, where in the end it's just a simple inequality, right? Going left or right. It wasn't in between two numbers. Like it wasn't 2 is less than x is less than or equal to 3, something like that. So you have to really think about it, or at least draw the graphs and look for the overlap.